Hi, someone asked me to work out section 9.5, problem number 5. I think Alicia did, so I'm going to go ahead and work this problem out in a screen share, and I'm just going to try to model for you exactly how I would approach the problem, and hopefully that will help. So here's the problem right here. We have x equals, see, becomes the problem. It's not the y squared, which is what you're used to. So, whoops, I don't want texting, hang on. Okay, x equals 1/2 y squared plus 3y plus 4. Okay, so I know this is a parabola. I'm already thinking that in my head. I'm also thinking to myself, okay, does it open up, down, or does it open left, right? And I'm already realizing that it's the y that's squared. And since it's the y that's squared, it's going to open left, right. I'm also realizing that the coefficient of the quadratic term is 1/2. It's positive 1/2. The y is the quadratic term here, and the coefficient of it is 1/2, positive 1/2. So I know this is going to open up to the right. All right, so let me see if I can, there we go, find something for my hand here. All right, so what I'm going to do, I'm going to find the x coordinate of the vertex and the y coordinate of the vertex. I'll start by finding the y coordinate of the vertex. Coordinates of the vertex. Okay, I don't feel like writing that all the way out. The y coordinate of the vertex is going to be the opposite of b over 2a. All right, so it's going to be the opposite of b, -3 over twice a. And remember, this is just a quadratic where a is 1/2. It's the coefficient of the quadratic term. B is 3. It's the coefficient of the linear term, and C is 4. It's the constant. So it's going to be the opposite of b over 2a. So it's going to be -3 over 2 times 1/2. Right? 2 times 1/2, so it's going to equal -3 over 1, or just -3. That's going to be the y coordinate of the vertex. Now the x coordinate of the vertex is just going to be a plug and chug thing. Okay, I'm just gonna plug and chug here. So I'm just going to put this in. I'm going to get 1/2 -3 squared plus 3 times -3 plus 4. So just plug it in because I know what y is. So if y is -3, what does x have to be here? So I know I'm going to take half of 9 plus, let's see, and then -9 plus 4. Isn't that going to be -5? So it's going to equal 9/2, and I hope 9/2 here plus, and then -5. -5 is the same as -10/2, and so really what I get here, when y is -3, x is -1/2. So there's the vertex right there. It's going to be -1/2, -3. All right, so let's go ahead and erase that. Okay. So what did I say? X is -1/2. When x is -1/2, y is -3. This is the vertex. All right, so, just thinking about it, at least, when x is -1/2, 1, 2, 3, 4, 1, 2, 3, 4, 3, 4, 5, 6. Just thinking about it. Okay, x is -1/2, so it's going to be about right here, right? And then down 3. 1, 2, 3. So it's going to be about right there. That's the vertex, and it's going to open right. So I don't know if it's going to be a big fat one, or a skinny one. I'm just not really sure, but I can see that it's going to cross the x-axis about right there, or excuse me, not the x, the y-axis, and about right there. So it'd be nice to be able to find those points, and also I could see that it's going to cross the x-axis about here, right? This is the y-axis, crossing the y-axis in those two places, and the x-axis right there. So it'd be nice to find those intercepts. So that's what we're going to do next, is find the intercepts. Finding this x-intercept is easy. Remember, you know, we're going to let y equal 0 here. To find this point right here, we let y equal 0. So if we do that, x is going to equal 1/2 times 0 squared plus 3 times 0 plus 4. So it's going to equal, you know, you could just see x is going to be 4. All right, so that kind of changes things for me, because look, I've got it intercepting at about 2, 0. So let me see if I can get a better point of intersection there. Let me see if I can graph this just a little bit better. I'm not sure I can. Now that I've already kind of put all this stuff on here, let me even change the color just a little, so maybe I can get. All right, looks like it's going to cross at 4, so right here. So I'm going to make this a little steeper than I just did, something like that. 1, 2, 3, and 4, and then it'd be the same thing over here. 1, 2, 3, and over 4. So about right here. It's got to do the same. It's got to be symmetrical about the vertex, you know, line going through the vertex right there. All right, so that's going to be the x-intercept. Now I have to find those y-intercepts, and they're a little trickier to find, but not too bad. What we'll do here, where it crosses the axes, right here and right here, the y-axes, those points, at those points x is equal to 0. So that's what we're going to do. We're going to set x equal to 0, then 0 is going to equal 1/2 y squared plus 3y plus 4. And I think I'll multiply everything by 2, so I'll get 0 equals y squared plus 6y plus 8, right? Because just multiplying, you know, both sides of the equation by 2, and 0 times 2 is 0. All right, now I'm hoping this factors, so I don't have to use the quadratic formula. It'd be nice. I think it does. Oh yeah. I'm already thinking of it. It's 1 plus 4, right? Y plus 4, and y plus 2. Look at that. Let's check it. Y times y is y squared. Yep. 2y, 4y is 6y. Yep. And 4 times 2 is 8. Yep. Yep. All right, so that's good to go. Didn't want to move that. I do want to move my yips out of the way. All right, so that tells me that it's going to intersect the graph at the points of intersection are y equal -4 and y equal -2. So if I just, you know, write them as ordered pairs, at this parabola that opens to the right is going to cross the y-axis at the point 0, -4, and 0, -2. So let's see if I look at that. All right, now that I have that information, that's why it's probably better to wait to actually plot these, because now let's see it. Okay, so it's right here. It's going to be up 1, 2. Oh, right over there. Wow. No, that's not it. Excuse me. At -2, right here. That's where it's going to be, right there. -2, and then 3, and then down over here, -4. Oh, there it is, right there. Yeah, there it is. And then here's my other points right here and here. So you know, can you see all my points right there? It's going to go through like that. Now that I have all my points, there it is. Beautiful. All right, and let me just see, was there anything else I was supposed to answer? Confirm your sketch. Well, just do it on your graphing calculator in the y equal editor. Oh, well, you can't. You can't really check that there. Do it in Wolfram. Oh no, Wolfram Alpha will switch the axes on you. Well, just turn your computer around, and it should look like that. If you just make the x-axis vertical and the y-axis horizontal, which we can do, by the way, then when you plot it on your calculator in the y equal editor, y equal 1/2 x squared plus 3x plus 4, it'll look the same. Okay, so I guess we can do that because we don't have that plotconic computer program there. I hope that makes sense. If there's any other questions, please let me know. Okay, bye-bye.